In scenario 2A, we used Johnson's rule to schedule the 5 cargo jets. Johnson's rule finds you the one order or sequence in which to complete the jobs so as to minimize the total amount of time required, or the make span. Yeah, okay, wait a minute, that was the scenario before, and that's all done. Johnson's rule tells you what order to process the cargo jets. It doesn't tell you all by itself how long that actually is going to take, or when you'll be finished with any one of the cargo jets, or whether any one of the cargo jets would be late, which is very natural questions that would then be asked about a schedule. You can see that in this scenario, that's exactly what's happening. We already have a sequence. If the 5 jets are scheduled as recommended in scenario A, how much time would be required to complete that sequence? That we never found out. Or would any of the courier jets be late for their departure from Edinburgh? Now, first off, wait a minute, the scenario before, what was this sequence right here? I can jot it down. We had determined that they should process the Belfast flight first, then the Dublin flight, then the London flight, then the Manchester flight, and then save for last the Birmingham flight. Birmingham. Okay, so I'm just jotting that there so that it's in front of us. We figured that out last time. Now we want to know, okay, fine, if you do them in that order, we know you'll get done in the least amount of time, but how long is that? And is any of them going to be late? And then in the meantime, we need a Gantt chart. At this point, the best way to extract answers to sort of follow-up questions like that is to draw a Gantt chart, is to simply illustrate that timing. And you can see that there is a blank Gantt chart frame already formed up here. Because, right, the issue with the cargo jets was unloading and then loading them again. There was one crew for unloading, one crew for loading. In a, whoops, it's crooked. In a loading Gantt chart, you'll have the rows, generally, are the resources that you're trying to schedule, and then the usually horizontal axis is time. Okay, now, this particular problem, we need to add a time scale before we do anything else. I'm trying to make a thoughtful selection of ink color here. Oh, thoughtful selection of scale. Right here on the left, that's definitely 0, or the right now, or the start of work. This particular problem with the data on the jets, a good scale is to let every column be 1/10 of an hour, which is actually 6 minutes, but we'll stick in decimal places. And I'm not going to bother to label each interval. I'm just going to go every other one. Like that's 0.2 hours. This is 0.4 hours. This is 0.6 hours, then 1, 2, 0.8. So 1 hour from the start of the sequence. 1.0 is right there. That's 1 hour out. And then 1.2 hours out, 1.4 hours out, 1.6 hours from the start, 1.8 hours from the start of work. Okay, here's 2 hours even. 2.2, 2.4, 2.6. Oh, okay, so the grid goes all the way out to, according to my scale, 2.7 hours. All right, fine. Now that was just housekeeping. That's getting set up. Because how do we illustrate the proposed sequence? Well, we look at who's in the front, and that's cut off here on the screen, but you can see that we decided that the Belfast flight should be first. Oh, okay, let's illustrate that. We know that we will work on the Belfast flight first. So the next thing we ask is, what does that involve? And if you have this note frame, the data that you need is at the bottom of the note frame. See, it says Belfast, matter of fact, all of the jets. Here was the original total duration, but here's what we're working with. First, they're unloaded. Each one takes a certain amount of time. And then they're loaded back up for departure, and that takes a certain amount of time. We were discussing in particular just Belfast. All right, well, Belfast is 0.2 hours of unloading and then 0.3 hours of loading. I need that information because here's one way to think about it. I'm going to book that time. 0.2 hours of unloading. It's first, so it's the first thing the unloading crew will do, and that's why I added a scale. There is 0.2 hours. I am booking their first 12 minutes of work because that's what 0.2 hours are. So, all right, this is used. I know what this is. This is Belfast. They're working on Belfast. Now, they're working on the Belfast jet, and as soon as it's unloaded and its cargo bays are clear, it can be reloaded, right? It means the loading crew can start up again. Okay, and according to the data, it required at 0.3 hours. That would be 3 columns in our scale. Here we go. I'm going to make a little note to myself. What is that? That's Belfast. That's us working on the Belfast jet. And at this point, I can answer the question, what is the flow time for the Belfast flight? Or, when will the Belfast flight be finished and ready to leave again? Those are equivalent statements. Because here it's being unloaded, here it's being loaded, I would just look at where it ends. Okay, well, it ends at between 0.4 and 0.6. It ends at 0.5 hours. That's our answer. And let me get the Belfast ink color. Flow time. Right here, 0.5 hours. Or the Belfast flight will be ready to leave again in a half hour after we start. And that, you think, well, I don't think you really needed to illustrate that. You said it was 0.2 hours of unloading and 0.3 hours of loading, and we're going to be doing it first. That's 0.5 hours worth of work. Well, duh, will be done in 0.5 hours. True. For the first job in a sequence, this issue of flow time is kind of obvious. It's for all the rest of them that the Gantt chart is helpful. Because, for instance, the next flight we'll work on is Dublin. The flight from Dublin back to Dublin. When will it be ready to leave? All right, well, I know I'll be doing it next, so let me book the time. I have to go down here and retrieve the correct data. Dublin, what do we know about it? It's 0.3 hours of unloading freight and then 0.35 hours of reloading freight, loading it again. Okay, so first, this 0.3 hours of unloading. That has to be done first. It will be done just as soon as they're done with Belfast. So I essentially book that time right after. And I have to be careful, it's 0.3 hours of unloading, so it's all right in here. Okay, there's us unloading the Dublin flight, and then as soon as it's done, oh, that's nicely timed. It's just kind of a coincidence, but as soon as it's done being unloaded, it turns out that the loading crew will free up. They'll finish Belfast, and they can start right away then on the Dublin flight. And it's 0.35 hours, so I have to be careful to grab the right amount of time. 3.5 columns. 0.35 hours. This is the Dublin flight. Right in here. Okay, Dublin. And when will the Dublin flight be finished? Well, when does it end? It ends right here just beyond 0.8. It's 0.85. The flow time for that flight is 0.85 hours. We now know that's when that flight will be finished. That's when that flight will be ready to leave again. We're done processing it. All right, you see how the Gantt chart goes? Then we go to the next one in the sequence and we book the time. The next one in the sequence is London. It seems like that was a big flight. London. London is a whole hour of unloading and then a whole half hour of loading again. Okay, a whole hour of unloading. Must be a lot of cargo. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because remember, these are each 0.1 hours. All of this in here is our unloading crew. Busy with the big London flight. Okay, there they're unloading it. Now, it's a half an hour of loading again, right, from the data. And here's where we want to be careful. Remember, the assumption is, and it's not just these cargo planes, it's all these two work center problems. You cannot start on the second process until you have finished the first process. Oh, which just means that we have to be careful to know when we actually finish unloading London. And it's out here at 1.5 hours. Fine, drop down, and that's where you start the second process of loading it again. That's only 5 of these columns. 1, 2, 3, 4, 5. There we go. So there we are loading the London flight. So London, wow. London, the flow time is 2 hours. We landed on 2 hours just exactly. Okay? Oh, it will be finished in 2 hours. If you wanted to leave immediately, it can leave in 2 hours. Now, we did leave a gap here on the bottom row for loading. It's true. We needed to leave that gap. That gap is essentially idle time. The loading crew will finish up with Dublin. The loading crew, the second crew, they'll finish up with Dublin, and there'll be nothing for them to do for a little while because they're waiting for the London flight to finish unloading. Johnson's rule, which originally created this sequence, here's its secret. Its secret is that it figures out the best way for all these blocks of time to fit together to minimize this kind of forced idleness, of which it generally can't, and you see it here, minimize it completely necessarily in all cases. Oh, but the Gantt chart at least can reveal when that's going to happen. All right. Now we're not done with the Gantt chart because we have 2 more flights. There's Manchester after London, right? Manchester is a half hour of unloading and then a quarter of an hour of loading. We will start unloading it as soon as we're done unloading London. So 1, 2, 3, 4, 5. Oh, another coincidence. This is Manchester in the green. And it will finish being unloaded right when the loading crew, the second crew, finishes up with the job before. That's great because we can then just schedule in, what is it, it's 2.5 columns. It's 0.25 hours of loading. Okay, and then where are we out to? That was Manchester. And the flow time, what is that? So that's 2.2, and it's a little half column 5, 2.25 hours. All right, following this sequence, we will, Manchester jet will be ready to leave in 2.25 hours. Okay, to finish the Gantt chart, that one last one, the Birmingham flight, I need a contrasting ink color, and I'll use pink. Manchester, excuse me, no, Birmingham. Oh, okay. It's actually apparently a small flight in terms of cargo because unloading is 0.15 and loading is 0.1, or only 1 column. Anyway, 0.15, there's the 1, split the column is the 5. Little bit of unloading being done here at the end. And actually, when they finish unloading the Birmingham flight, this is the Birmingham flight, when they finish unloading the Birmingham flight, it'll just have to wait because the second crew's still busy with Manchester. But when they free up, it's just 1/10 of an hour of loading to do again, but that's actually taking this half column and this half column. That right there, it's a small job. Birmingham. That's the Birmingham flight, and then the flow time, well, when does it actually wind up ending? It is just shy of 2.4 here, so the flow time is 2.35 hours. So first off, I have finished a Gantt chart illustrating the Johnson's rule sequence. Second, I have found the flow time of each of the jobs, so to speak, each of the jets in that sequence. Now, did I actually answer any of the questions that were asked? What was the questions that were asked? If the 5 jets are scheduled as recommended, okay, that's according to here, how much time will be required to complete the sequence? Another way to say that is, what is the make span? Oh, I can answer that because I just look at my Gantt chart and I look at how much time in total, starting from 0, did it wind up taking? And that's the flow time of the last job. That's what's right here. Answer. 2.35 hours. 2.35 hours, because by the time I plotted everything, that's how much time it took. So that's what the Gantt chart reveals to us. That is also, we know, 2.35 hours. That is also the absolute least amount of time that it could take to unload and then load each of these 5 jets. We know that because we got the original sequence from Johnson's rule, and that's what Johnson's rule guarantees. Now, what Johnson's rule doesn't guarantee is anything to do with timing or tardiness. You say, what? Yeah, it ignores, for the individual jobs if there's any issue of timing, like a promised completion time. And that was the other question, though. Will any of the courier jets be late for departure? We have what we need here to answer that question. We need to know, though, what did we promise in terms of departure for each of these 5 jets? That was supplied in the earlier scenario. We've actually been working with that data for a while in the earlier scenarios. It's not pre-printed on this particular note frame, but I have it. I wrote it in my notes, and you can look it up. You can see this in the previous scenarios. For instance, the scheduled departure time for Belfast right now is 1.0. The scheduled departure time is 1 hour from now. The question is will any of the jets be late? The best way to answer that is to just check each jet. Belfast, scheduled departure, scheduled. Whoops, I misspelled scheduled. Scheduled departure, 1.0 hours from now. It'll be done in a half hour. Now I'm just checking. This is when it was promised. It won't be late. Not late. Not late. Matter of fact, it will be finished and could leave a half hour early. That's what we're checking for. Okay, so the next one is Dublin. Dublin, we know will finish in 0.85 hours, and then we have to look up from the original information. Dublin, when did they say it would depart? Scheduled departure. Maybe I can spell it right this time. Scheduled departure. Okay, this is just the fact from the earlier scenario. Okay, let me get the right flight. 2.0 in 2 hours. It's scheduled to depart in 2 hours. It's scheduled to depart in 2 hours. We will be done with it in 0.85 hours. That one's not late either. Not late. Not late. Okay, now London. London, I'm looking up in the original data. London, the scheduled departure time is way out there, 3 hours from now. That's good because it's a big flight. I'll just go ahead and note that right on the note sheet. Scheduled departure, 3 hours. 3 hours out. We'll be done with it in 2 hours. That's another case of no problem. Obviously, it's not going to be late. Now, right in here, up in here, Manchester. I got to look up what was the scheduled departure time for Manchester. The scheduled departure time for the Manchester flight, in my notes, it's jotted down 1.5 hours or 1.5 hours from now. Okay. Manchester might be problematic. Manchester, scheduled departure. This is just a fact. We were planning on 1.5 hours from now. We were planning on this. I'm looking over here. If we follow the Johnson's rule sequence, that particular flight will be finished in 2.5 hours. Its flow time is larger than its due date. that is lateness. That's tardiness. That flight is not going to make its scheduled departure time. So the answer to this, the absolute short answer to the question up above here is simply yes. Because actually what the question asks is, will any of the jets be late? Yeah. It would be nice to provide like a little bit more of information. We have spotted that Manchester, and before I finish writing this response, maybe I better check the last one as well. I don't know, maybe the Birmingham flight's going to be late, because I've got to look up when the scheduled departure for Birmingham was. Scheduled departure for Birmingham, 2.6 hours. Oh, no problem. Then we're talking about Birmingham, the last one, the little one. Scheduled departure from the original information, 2.6 hours out. It will be done in 2.35 hours. It's not late either. Not late. So we can say definitively Manchester will be late. How late? Let's see. We'll be done in 2.25 hours. We had promised, or we had planned for that flight to leave in an hour and a half. So at this point, if we follow this sequence, it's just basically simple arithmetic or logic. It's going to be 0.75. It's going to be 3/4, 45 minutes late if we follow this particular sequence. However, all 5 of the jets, if we follow that sequence, will get finished as soon as possible.